So I'm going to talk about 3 origin stories of the internet. So I love history. When I was in university, I was a history minor, and I really enjoyed it. But then computer science took over my life, and I'm now looking for excuses to get back into it. So I've been reading a lot about the internet's history. So I just want to share a few stories that I came across. So our first story is Vannevar Bush, and he built something called the Memex. So I'm going to talk about that now. So Vannevar Bush had a problem. He was drowning in paper. During World War II, there was an explosion in bureaucracies, and paper was flying around everywhere. There was more reports and correspondence that was being produced than ever before. Information was everywhere. So during the war, Vannevar Bush was the director of civilian research in America. Time magazine called him the general of physics. And each day, his desk was flooded with paper. His organization was producing about 35,000 reports over a few years, so it was just overwhelmed. He said, "We're being buried in our own product. We have all these tools to produce information, but not too many to understand it." And this problem was going to be really urgent because he knew that in a couple of months, the first atom bomb would be deployed. He was actually a secret director of the project. And he was concerned that we're losing our ability to stay on top of information, and then we're also gaining the ability to blow up the planet. So he was really worried about this. So when the war came to an end, he thought about solutions. He said, wouldn't it be amazing if there was a device that would store our information, let us navigate it, let us understand everything that we came across? And he had some experience building devices. This is an analog computer that he'd built. And he came up with a device called the Memex. So it would be a desk-sized device. You'd put all your information in it. You'd be able to organize it. You'd be able to search it. And you'd be able to display things on the screen in the middle. It came with some really cool add-on devices like this camera that you'd mount in the middle of your head. It would input data into your Memex. Had this touchscreen device so you could add notes. Had a voice recorder that you could add notes into. And the coolest feature about the Memex was this idea that you could link together arbitrary pieces of information and then be able to navigate them. Sounds a bit like hyperlinks, and we'll see the connection later on. So this is a pretty radical idea for the time. Computers basically didn't exist at the time. This is the ENIAC, and it hadn't even been invented yet. It would be a few more years before the first digital computer would come out. If you walked into a room in the 40s and you asked to see the computer, this is what you would see. So generally, computers were people doing manual calculations, usually women, and they would sit around and do calculations. They'd do things like missile trajectories or calculations like that. Here's another picture. If you look at the top left, you can see it's called the computing division. So this was a computer in the 40s. So the idea of a single person sitting in front of a screen and using a computer was pretty new. Like, nobody had thought about it. So it caused quite a stir when it first came out. The problem is it was never built. It was a bit ahead of its time. But the idea didn't die, just the opposite. So we're going to go to story 2. This is Doug Engelbart and his demo. So in World War II, Doug Engelbart joined the Navy. He got trained as a radar operator, and just when he got deployed, the war ended. So he ended up in the Philippines with a lot of time on his hands. So one day, he stumbled on a library. It was run by the Red Cross, and he stumbles on the essay with the Memex in it, and it was like a bolt of lightning. These are his notes in the essay that he read. And he decided then and there that he would devote his life to making this Memex a reality. So it took 15 years, but he finally got funding at Stanford to try and build this Memex. And he wanted to build a system that would let people organize information, navigate it, and really understand complexity. So he put together a pretty quirky team. People would stand around and collaborate in front of screens. People had meetings on the floor. People were comfortable putting their feet on the desk. People were comfortable bringing joints into the office. I'm sorry if this is not, it might be a cigarette, but there was definitely marijuana in the office. Everybody was doing LSD, including Engelbart. People grew their hair a little bit. Even Doug Engelbart grew his beard out. People had standing desks. People had yoga desks, they call these. So it was a pretty wild time. And even by California standards in the 60s, people thought he was weird, and people thought his group was weird. And he'd smile at them and say, "You'll all be doing this one day." So early versions of his system kind of looked like the radar screens that he was trained on. And they used a technique where as they were building the system, they would use their own system to build features. So he called this bootstrapping. Today we might call it eating your own dog food. So early versions of his system looked like this. but they kind of evolved into something that might be pretty familiar with, someone sitting in front of a screen doing work on a computer. And it seems kind of boring to us now, but this was a computer in the 60s. Generally, you'd use it with a punch card, you'd input your data, and then you'd wait for a computer to do its thing, and you get a printout of the results. That was what computers were. So it was a pretty new idea. The problem was that he had trouble communicating what he was doing. Nobody really got it. So he said, I'm going to do a Hail Mary, I'm going to do a big demo in front of thousands of people and do a live demo, the famous last words. But he decided to do this in San Francisco. So it was carefully prepared. Here's him rehearsing. It was a pretty big operation to get this together. Here's the room. Unfortunately, there's no pictures of him doing the actual demo, so you just have to pretend that there are thousands of people in this room, and their jaws are hanging open, because what they saw was like a religious experience. Here's some of the things that the world witnessed for the first time in that 90 minutes. There's the first mouse on the right. Nobody had ever seen this before. It's completely new. It was the first interactive text editing. So here's Doug Engelbart working on a shopping list that he was putting together, and you could navigate it and edit it in real time. People saw hyperlinks working for the first time. He had early versions of wikis, email, source control even. Nobody had ever done this with computers before. And as a final wow, he video conferenced in team members, and they did a collaboration over a couple of kilometers. So this is totally new, and it changed computers forever. So let's do a little interlude about the ARPANET. Some of you might have heard it. So ARPA was a research and development arm of the US Department of Defense. And the majority of their time in the 60s was coming up with horrible ways to win the war in Vietnam. There's some pretty interesting history here. But they decided to fund a small experiment in networking computers together. Some people talk about ARPANET as being designed to survive a nuclear attack. This is not technically true, but it was kind of in the background at this time. But the real goal was to test out something called packet switching. This was a new idea in networking. And traditionally, networks are organized like on the left with the centralized services. And the idea was to break down packets break down information into little packets so you could move them around the network individually and then reassemble them at the end. So this was a new idea, and they wanted to test this out. So when Doug Engelbart heard about this cool new thing called ARPANET, he's like, I'm on board, this is a great idea. And he immediately got to work helping to organize it. So this is a meeting he ran, he helped run for planning the ARPANET, and he used computers. Like nobody had ever run a meeting with an agenda off a computer before, so this was one of the first. But he immediately recognized the potential. So ARPANET got off the ground pretty fast. This is one of the first internet routers, so it was a big device that would network together two computers. So the first two computers on the ARPANET were these people at UCLA. These are they're standing around getting ready, and Doug Engelbart's group in Stanford. So they got ready for the first transmission. So they used one of these things, it was a teletype machine. So the programmer typed in L, and then waited, it transferred, it typed in O, then in G, and then nothing. And the computer had crashed. They were trying to run the login command, but there was a buffer overflow. So they recompiled the kernel, and they fixed the buffer size. They recompiled, and then 15 minutes later, the first message was transferred, and that was the internet. It had begun in 1969. So this was the internet in 1969, UCLA, Stanford, Utah. And then by 1972, the network had grown a bit, but there was a problem. People weren't into it. Like, it wasn't really popular. For one thing, computers were scarce resources, and people didn't want random undergrads logging in and taking up computer time. This was not something that people were too into. The other problem was that ARPA was really interested in the hardware engineering part of this project, and they built really cool routers. But when it came to software and protocols, they didn't really care. That was a user problem. So people were having trouble actually understanding and getting onto this network. In 1972, there was going to be a big demo of ARPANET, and people hoped that this would really drum up enthusiasm for the project. So this brings us to our final story about Elizabeth Feinler and the Network Information Center. So she was working in the same building as Doug Engelbart. She ran a group that did literature search for chemists, and she would hang out with Doug. And she heard about the demo coming up, and so Doug came up to her and she was like, I got a job for you. We need a resource handbook for the internet. So she says, what's a resource handbook? And Doug Engelbart was like, I don't have a clue, but we need one in 6 weeks. So what had happened is that the ARPANET people, they needed to build this document, and they kind of got distracted by shinier problems, and they forgot about it. And as the demo was coming up, they didn't have anything in place. So Elizabeth Feinler got to work on this and produced one of a few thousand, almost 1,000 pages of documentation that helped people get online. And the demo was a big hit. People enjoyed it, and I think a lot of people came onto the ARPANET because of this demo. So over the next 20 years, Feinler played a huge role in shaping the internet. I'm going to go over some of the ways. When new users would connect to the ARPANET, there was no Google to help figure out things. There was the NIC, the Network Information Center. This was the group that Elizabeth Feinler started running in 1972. So at the beginning, they focused on things like hard copy documentation. They ran a toll-free hotline, and they would just answer questions about how the network ran. This is one of the directories that they mailed out. It listed everybody on the internet. They began adding interactive services. They had the What Is service, and you would log in and see what computers were available on the network. They ran the Who Is service, and you would put someone's last name in, and you get their contact information. By the way, when I was researching this, I came across a tweet. This is her. She's still alive, and she tweeted recently. When she was joining Twitter, she's like, we did this Who Is thing a long time ago on Twitter. So I thought it was pretty funny. So this is what you get with a Who Is service. You'd put someone's last name, and you get their IP address. You get their where they worked. So one day the military, remember the military was the sponsor of this project. They came to her and they said, we want to add ranks and titles to this directory. And she kind of made up an excuse. She said, no, it's a bit too hard to implement technically. But really, she didn't want to add ranks and titles to this directory because she wanted people to be comfortable talking to anybody else on the network. And she was really happy that sometimes Nobel Prize winners would talk to 16-year-olds and they wouldn't even know it. So documenting the ARPANET, ARPA mainly cared about the hardware, and the protocols were sort of left to the users. And the NIC played a big role in just helping this process. Feinler and the NIC made sure that a wide variety of people participated. They handled the documentation and the backups when programmers forgot to do this inevitably. And they made sure that everybody at the end of these meetings and planning sessions got these copies of the information. People were pretty iffy about the ARPANET until email came about, and this was about in 1971 and 1972. It was the first killer app, and as soon as it took off, it was eating up the majority of the bandwidth on the network. Most importantly for users, you didn't have to remember an IP address to reach people. You could just remember a host name. And this made email really easy to use. So Feinler's team was responsible for having that table that translated a host name into a network address. This is an example of what it might have looked like. You can see it's just a list of host names of the person and the network address. So at first, this was done by just sending out a copy of this table to all the administrators manually. And then they automated this. It became cumbersome. So they had an ASCII flat file, and then administrators would log on FTP and copy over that host name onto their own machine. So just to clarify, the whole internet's host table was on a single file that people would have to manually copy over to their computers. So this is like, it was a pretty small network at the time. The problem is that if an admin was lazy and didn't keep up their table, the whole network would start bouncing and requests would really not go through. So she had to spend a lot of time just convincing people to keep their host tables updated, and it was a big impact on the network. So as the ARPANET grew, people wanted their own host names at the top level, and this, there were a lot of fights about who could have a host name and like what the rules were. And Feinler looked into the future and said, if this keeps growing, this could be a bigger and bigger problem. So she decided to split up the network into various top-level domains that could be administrated separately. So, the military could have their own domain, the government services, education services, orgs, businesses. Well, at the last minute, someone realized that .buzz was already being used for hardware, so they went with .com. So every time there was a protocol to update, Feinler would stay up all night, make sure the protocol transition happened, everybody was updated, and then she would stay at the office the next day to deal with all the services and the customer service. And she drank a lot of Mountain Dew at this time, she says. So the biggest migration was the migration to TCP/IP, and this was a new protocol that was coming out. And it happened in 1983. The military imposed this deadline on everybody, and they pulled it off, and it worked. And at this point, the ARPANET went from being a research network into an operational network. So the NIC became more important than ever. Feinler's role grew, and by the time she left, she was managing about 45 people. So it was a pretty big deal. So let's think about the legacy a little bit. ARPANET wasn't the only network at this time. I think people kind of like talk about the ARPANET as, as if it was a linear progression to the internet. It wasn't. There was a lot floating around. France had their own network. It was called Cyclids. Then they had a sort of a similar version called Minitel, where people could dial into this network with their TV and phone. Canada actually had a version of this called Teledon. That's pretty interesting history. There was a service called Plato where people could use messages, emails, forums, and this was in the 70s. The Soviets had a network. The corporations all had networks. There was Ipsonet in Canada, actually. This is pretty similar. So the question is, why did the internet win? And this is a big question. It's hard to answer. Obviously, having the backing of the American government had a huge impact. But I think also the idea of letting the users run the network and decide the future of it was a pretty big deal and a pretty good idea. And FineLearn and the NIC really helped shape this and make this process work. So in researching this talk, I came across a post that she made like years after she had left the NIC, and people were fighting about the domain system. They were griping, complaining, and she kind of swoops in to give some wisdom. So she says, I originated the top level domain system. Don't worry, don't worry, everything's fine. Just trust the process. And just remember, in the heat of battle and the exchange of ideas, it behooves us all to remember that we are engaged in international discussions amongst peers. We should be a little kinder and gentler to each other. And then she just kind of summarizes like the way she was a leader on the internet. She says, global feedback and consensus are what have made the internet great. It's a chaotic democracy and not a cartel conspiracy. So I think it kind of summarizes the impact that she had on the culture. So to conclude, I think I've picked 3 stories that, obviously a lot went into building the internet. There's a lot of contributors, but they sort of represent the types of work that, that went into making it. So we have someone like Vannevar Bush that really opened up the idea space and showed us what was possible, showed us a new idea. There's someone like Doug Engelbart who took this and made it work. Sometimes in academia we say publish or perish. In tech sometimes we say demo or die. So you really have to show the goods. But then there's someone like Elizabeth Feinler, and she never learned to program. She didn't really get involved in the nitty-gritty technical discussions, but her years of writing, phone calls, emails, like they had a huge impact on the version of the internet we have today. And she convinced a whole bunch of people with big egos and big ideas about what the internet should be to work together. And I think most impressively, she did this all in the Cold War when people were paranoid and people were protective, and she made sure that everything was done in the open and transparent. So I have another concluding thought. The stories of Vannevar Bush and Doug Engelbart are well told. Has anybody heard the stories of the Memex or Doug Engelbart before? Yeah, so some hands. Has anybody heard the story of Elizabeth Feinler before? No. So I think you see where I'm going with this. The origin stories we tell about technologies and our histories are really important. So I think we should all really try to understand, like, are we missing types of works? Are we overlooking types of people? And let's just think about that when we tell our own histories. So if you like this story, I have a newsletter. You can sign up. And I'm going to put the slides on my site, and they have a lot of links where you can find out more. Thank you very much.